Hello everybody and welcome to the Unified Firmware Guide video. If you're watching this, it's probably because you're wanting to upgrade your stock printer to get some more features and better print quality, or you purchased one of our products like the EZABL or the EZOut sensor. So we're going to go over today how to actually get this set up and onto your printer. Stay tuned. Now this firmware is built on top of the widely used firmware called Marlin. What we did is we started out with a base build of Marlin 1.1.8 and we started patching features and fixing bugs so we can get a stable firmware that is up to date and ready to use for our customers and anybody else that just wants to upgrade their printer. What we're going to cover today is actually how to use that firmware and how to get it onto your machine. Now, I do have to put a disclaimer here. This is at your own risk, so if you break your printer board or your printer catches on fire or explodes, it's not our responsibility. This is provided as is and is at your own risk. Now we've got that out of the way. If you have a CR10 or Ender 2 printer, what you're going to want to do is go and watch the bootloader guide, which I'll post a link here in the corner. And what that's going to do is show you how to get the bootloader on your printer. You need to have the bootloader on your machine before you can update the firmware if you have a CR10 or Ender 2 or any machine typically that has the 1284p chip on it. If you're not sure if your printer has a 1284p chip on it, go ahead and shoot us a message at th3dstudio.com. You can hit the contact us button there. Before we get into actually using the firmware, there's a couple things you have to have set up. And one of those things is the Arduino IDE. Now, if you're on a Windows machine, we provide a fully set up Arduino IDE that is ready to go. If you're on Mac or Linux, then if you look on our website, there's a Mac IDE setup guide, and that'll show you how to load the libraries. Linux is the same setup procedure. So essentially, you're going to install the Arduino IDE software. We recommend version 1.8.5, and the Mac version is included in the download. And then you're going to install what are called hardware libraries. And if we go over here to my other screen, you'll see I have the unified firmware already extracted here. So I'm going to open that up here. And this may be a little too small because it's a 4K monitor. But there's going to be 5 folders here: extra programs, firmware, Mac OS X Arduino, mounts, and Windows Arduino. So if you go into the Mac OS X Arduino folder, what you're going to see is an Arduino-1.8.5-Mac OS X. That's the actual Arduino IDE, and then TH3D Arduino libraries. If you open up these libraries, you're going to see 2 folders in here, Sanguino and Arduino. And these 2 folders need to be put in the hardware folder for your Arduino installation. That's typically the program files folder where it gets installed to. And again, that's covered on the guide. So since we're on a Windows machine, we're going to use our included Windows Arduino IDE. So to open that up, you can either do it one or 2 ways. We have a shortcut here, which is just a batch file that'll load the firmware directly with our included Arduino. But we're going to show you how to manually open it just in case that doesn't work for you. So you're going to go into the Windows Arduino folder and double click arduino.exe. Now this is loading up here, and then I'll bring it over to my screen that we're doing the capture on. And it will take a second to load up. It is a Java-based program, so it can be a little slow at times, but this is the Arduino IDE. You'll see our logo pop up, and it'll say Arduino 1.5 Portable. So now, this already has our firmware opened in it. If for some reason you open it and it doesn't, what you're going to want to do is go to File, and then Open. And then it's going to bring up a browse window here, and you're going to browse to where you extracted the file. So because this is on my desktop, I'm going to go down here and I'm going to search for the TH3D Unified Firmware. So I'm going to go here, open this up, go into the firmware folder, and then TH3D UF, and you're going to search for a file named th3duf.ino. And if you have Arduino installed, it'll show up as this little green icon. So we're going to go ahead and open that up. And it's going to load up here. So when it opens up, you're at this all settings are changed in configuration H file. So you're not going to do any changes except for in one file. So up at the top, you'll see all these tabs across. And you're going to select configuration.h. And there is a how-to in here. And basically, I'm going to show you how to use this. It's very simple. This is completely overhauled from how Marlin does this standard. And we're going to show you how to use our version of it. So if you scroll down, you'll see a banner here. It says TH3D configuration, and each printer is set up into sections. So you'll see here Creality CR10 options. If you scroll down, you'll see Creality CR10S options, and so on and so forth. We got the Ender 2, the TiVo Tornado, and the Lulzbot TAS5. That's what's currently in this release as the time of we're shooting this video, which is January 21st. We will be adding on more printers to this unified firmware, so you can expect to see more add-ons and whatnot in terms of printers that are supported in this firmware. But it's very simple to use. It doesn't matter if you have a CR10, a Tornado, a Lulzbot. It's all the same setup procedure, and you're only going to modify the options that are in the section for your printer. So if you have a CR10, you're not going to modify anything outside of this in terms of basic setup. Now, we have set up here on our bench is a stock CR10S board and LCD. So we're going to set this up, and you can see this is the stock firmware that Creality ships with it. And I'm just going to show you here how to enable the actual options to get this firmware on your machine. So since I have the CR10S for this example, I'm going to uncomment this hashtag define CR10S. And uncomment just means deleting those 2 forward slashes. And you'll notice if you did it correctly, the hashtag define will turn green. Now at this point, I can go ahead, the firmware is set up for this board, and this will be for a stock printer. Now, before you can actually upload this to the board, you got to select your correct board from at the top. So if you have a TiVo Tornado or a CR10S, you're going to want to make sure the board selected is Arduino Mega 2560, and the processor is ATmega 2560. Now, the COM port is the COM port your printer board is on. In this example, on my computer here, this board is connected to COM5. So I'm going to select COM5 here, and then I'm going to hit upload. And you'll see down at the bottom, it's saying compiling sketch. Now, this is going to take a few minutes, depending on the speed of your system. This takes about a minute or 2 on my system. So I'm going to go ahead and cut this chunk out and come back to it. And then it'll show uploading to the board. So we'll come right back after this starts compiling the sketch here. Okay, now that the firmware is actually done compiling, you'll see in the bottom left-hand corner it says uploading. If you look at the LEDs on the board here, you'll see they're flashing rapidly. That means that the firmware is being uploaded to the printer. So it's going to take about 30 to 40 seconds on average to upload the firmware to your board. Now, not all boards have flashing LEDs, so this may vary depending on the board you have. For example, the CR10S has the LEDs, whereas the CR10 and the Ender 2 boards do not. But as long as it says uploading, then you're good to go. One thing you'll notice is when it's flashing, if you press the button, nothing happens. If the LCD screen is locked, that means it's successfully uploading to the board. Once this is uploading to the board, the screen will refresh, and then you'll see our logo. It'll then also say the version number you're running. In this case, this is the Beta 5, and you'll see the TH3D Studio. And at this point, the firmware is on your board. So if we go ahead and press the button here, you'll see that it's loaded. And the menu will look a little different because this is a newer version of Marlin compared to what is shipped on the printer. Now, this is for a stock machine. If you have a printer that is running auto bed leveling, there's a couple other steps we have to do. So we're going to go back over here to Arduino IDE, and we're going to turn on auto bed leveling. And this is just as simple as we set it up for the actual printer board. You come down here and you search for the EZABL_enable, and then uncomment that. In addition to that, what you're going to do is you're also going to select what mount type you're using. And in this case, this board has 4 different predefined mounts as well as a custom option. So if you're using the OEM mount that we bundle, you can go ahead and uncomment this. Now, all of these mounts are actually included in the download package. So if you go back to where you extracted your files, there's a folder called mounts, and then a folder for each printer model. Now, the CR10 and CR10S use the same mounts, and they're all located in here, and they correspond with the probe mounts in the actual Arduino. So whichever one you print out, that's the one you need to uncomment. Now, if you have one that's not one that we have predefined here, what you can do is, instead of uncommenting this, you would go down and uncomment define custom probe. And then scroll down, and you'll see here, if you have a custom probe mount or one that is not pre-supported, uncomment it, and then enter your probe location. Now, your probe location is where the probe is offset on X and Y. And you can see from the example here, it's on X and Y on a straight line, left to right, front to back. It's not on a diagonal. So you're going to need to measure that and input this in here, and this is in millimeters. So in this example here, you can see if the nozzle's at 1010, the probe's at 2020, that means the probe here in this example is offset by 1010, which is what the default is here. So you're going to want to change these options right here for your custom probe. Since we're not going to be using a custom probe in this example, I'm going to go ahead and comment this back out and uncomment the CR10 OEM. And that's it. So now this board is ready to be flashed with the EZABL firmware. I'm going to go back up here again and hit upload. Now, if you want to double check, you can also check your port and processor and board. This should not change if you have not closed out the Arduino IDE. I'm going to go and upload, and this time it'll actually compile a bit quicker because it's got a previous compile cached in memory, and it's going to go ahead and just recompile the portions that it needs to do to enable the auto bed leveling. And the procedure will be the same. It'll take a minute or two to compile. It'll upload to the board, and then one way you can verify that it actually did upload to the board is that instead of saying TH3D and then the version number you're running ready, it'll say TH3D EZABL ready. You can see that the firmware has now loaded and it's resetting the board, and now it will say TH3D EZABL ready. So now this board has the EZABL firmware loaded, and you can use it with our probe. And it's that simple. So the only other couple things I want to cover here is just some extras and the actual line for our EZOut, which is a filament sensor kit we have for the CR10 and CR10S. It's the same procedure here. You can just go to the hashtag define EZOut enable line and then uncomment it, and that'll enable the EZOut sensor. Now, since I don't have an EZOut sensor handy to show you on this board, I'm not going to do that, because what will happen is if you enable EZOut, when you don't have an EZOut sensor, the beeper is going to make a very loud noise, because the EZOut filament sensor kit actually repurposes the beeper pin to use with the filament sensor. Now, if you scroll down here, you're going to find a section called TH3D Extras. And these are just tweaks and other add-ons that we put into the firmware to give you guys more flexibility in terms of being able to change your EZABL points in terms of how many points you want to probe. By default, you can see here it is set to 4. So that's going to do 4 probes on X and Y. So when it probes, it's going to go 1, 2, 3, 4, move down 1, 2, 3, 4, and repeat. So that's 16 points total. If you want less points, you can go ahead and just change this number from a 4 to a 3. Or if you want more points, you can change it to a 5 or even a 7. It's going to take longer to probe the more points you have. Typically, 4 is a good number to have. On my CR10, I run a 3 grid instead of a 4. On my S4, I run a 4 grid. We put the default setting at 4 because it works on most people's machines. Under that, you'll see a hashtag define binder clips. And what this means is if you uncomment this, it's going to set the probing points 50 millimeters in on the edges of the bed instead of 30, which is the default. So if you get rid of the 2 forward slashes here, you're going to have the probing in 50 millimeters instead of 30. Now, one thing that's cool about our firmware is when you put your probe offsets in, like if, for example, if you have a custom probe or when you uncomment one of our pre-supported probe mounts, the firmware is automatically setting up all the probing points based on your bed size and the probe location. So you don't have to mess with any of that. Underneath the binder clips, we also have linear leveling. Some machines do better with linear leveling than others. So if you're getting a auto bed leveling result where one side is always higher than the right and you've checked all your mechanical portions of the printer, go ahead and uncomment the linear leveling line here. And that's going to change the type of leveling from bilinear to linear, and it just gives you a different result. Go ahead and play with it and find the one that works best for you. Underneath that is the V6 hot end option. If you're using an E3D V6 hot end or you're using our hot end with the supplied thermistor, you're going to want to uncomment this as well. And this will change the thermistor from the stock printer hot end thermistor to the E3D or the TH3D thermistor to give you a more accurate temperature reading. Now, we have two options here for AC beds. If you uncomment the define AC bed option, that is going to disable the bed heater completely. And the reason you want to do this is because if you have an AC bed that's completely separate from the printer, meaning it has its own controller, you don't want to accidentally turn on the bed and it'll give you a thermal runaway because the printer can't control that heated bed. So I recommend go ahead and uncomment this if you have an AC bed like the Kenovos that have a separate controller in terms of temperature controller. If you're using an AC bed with a solid state relay, meaning your board can control it, go ahead and uncomment this if you are using the Kenovo thermistor that is part of the Kenovo bed. If you're still using your stock printer thermistor, that is perfectly fine, but you do not need to uncomment this unless you are using the Kenovo thermistor that comes with the Kenovo heating pads. There's a couple other options here as well for the Titan extruder, which is for the E3D or the TH3D one. And when you uncomment this, what happens is it inverts the extruder direction because of the gearing on them. You need to invert it. So this does that automatically for you, and it changes the steps per millimeter from the stock printer one, which is typically about 95 for most printers, to the 463. Now, if you need to change your steps per millimeter for the Titan, you can go ahead and change it here, or you can set it in what's called the EEPROM, meaning you send a G-code command to the printer and it'll change the steps and it'll keep that stored between restarts. But if you want to hard code in your firmware, this is where you would do it. The last other two options here are the Tiny Machines boot screen. Tiny Machines is a good friend of ours and they use our firmware with their machines. So we have an option here for them to easily add their boot screen. If you are a Tiny Machines customer and you want to see their boot screen instead of ours, you can just go ahead and uncomment this and that'll show their boot screen instead of the TH3D. If you want to set a custom printer name on your printer, you can go ahead and uncomment this and then change this portion here inside the quotes to whatever you want. So if I want this to be Tim's Awesome CR10S, I can put that there and then it'll say Tim's Awesome CR10S ready when I go ahead and upload the firmware to it. So I hope I've covered everything that you guys want to see and any questions you had about the firmware. We're going to be adding on more features and more printers, so hopefully this video will still stay relevant, but there aren't going to be any major changes. It's always going to be the same type of setup. Basically uncomment your printer type and then uncomment any other options you want or have on the machine and then upload. It's that simple. And this is the same process for any platform. So as long as you have the Arduino IDE set up on your Mac or your Linux computer, it doesn't matter as long as you have the Arduino IDE set up. If you have a Mac or Linux system and you do not have the additional hardware libraries loaded, you will get errors when you try to compile, and you need to add those hardware libraries to your Arduino IDE per the guide on our site in order to be able to upload this to the board. So I hope this has been beneficial to everybody, and I appreciate you guys' time and support, and enjoy printing.